Welcome again to my YouTube channel, and for this video, our topic is all about positive integral exponents. Here, we will tackle the product of powers, power of a powers, power of a product, quotient of powers, and power of a fraction. Integral exponents is a power of a number in the form of an integer. To simplify repeated products, mathematics makes use of exponents. Let us study positive integer as exponents. So look at these products. So we have 8 times 16 equals 128, and 9 times 81, we have 729. Replace the factors by a power of 2 and 3 respectively. So we have, for 8, we have 2 to the power of 3, and for 16 is 2 to the power of 4. To multiply this, just copy the coefficient 2 and add the exponent, which is 3 plus 4, which is 2 to the power of 7, which is equivalent to 128. And for 9, we have 3 to the power of 2. And for 81, we have 3 to the power of 4. And that's what we have done in 8 times 16. So, just copy the coefficient 3 and add the exponent 2 plus 4 equals 6. So, our answer is 3 to the power of 6, which is 729. So, product of powers. For any number a and positive integers m and n, we have a to the power of m times a to the power of n equals a to the power of m plus n. For examples, so we have 2 to the power of 3 times 2 to the power of 4. So as what I have said or discussed in the previous slide, so we just copy the coefficient, which is the 2. Then add the exponent, which is 3 and 4. So the result is 2 to the power of 7. For number 2, our given is 5x cubed times 4x. So we will use commutative and associative property. So we have 5 times 4 times x cubed times x. So 5 times 4, we have 20, and x cubed times x, we have x to the power of 3 plus 1. So, our answer is 20x to the power of 4. Let's proceed to number 3. So, our given is x cubed, y squared, x, y to the power of 4. So, let's solve. So, we have x cubed times x. So, we have x to the power of 3 plus 1. Then, y squared times y to the power of 4. We have y to the power of 2 plus 4. So, our answer is x to the power of 4, y to the power of 6. For example, number 4. Our given is 3a to the power of 2 times negative 5ab times 2b to the power of 3. So, as what we have done in the previous examples, we will use commutative and associative properties. So, we have 3 times negative 5 times 2, a times a to the power of 2 times a, b times b to the power of 3. So, we have 3 times negative 5 times 2. So, we have negative 30. And a squared times a, we have a to the power of 3. And b times b cubed, we have b to the power of 4. So, power of a power. For any number a and any positive integer m and n, a to the power of m to the power of n equals a to the power of mn. For example, number 1, our given is quantity of x squared to the power of 3. To solve this one, we will multiply the exponents. So x, copy the coefficient x, then multiply the 2 times 3. So the answer is x to the power of 6. For example, number 2, a cubed, quantity of a cubed to the power of 5. So as what we have done in the number 1, just copy the coefficient a and multiply the 3 and 5. So the result is 15. So we have a to the power of 15. And for number 3, our given is quantity of y to the power of 4 raised to the power of 2 equals, copy the coefficient y and multiply the 4 and 2. So the result is 8. So our answer is y to the power of 8. So we are here, power of a product. For all numbers a and b and any positive integer m, ab to the power of m equals a to the power of m, b to the power of m. For example, quantity of ab to the power of 3 equals a to the power of 3 times b to the power of 3. So we distribute the exponent to the coefficients inside the quantity symbol. So we have a to the power of 3 and b to the power of 3. So our answer is a to the power of 3, b to the power of 3. For number 2, 2x to the power, quantity of 2x to the power of 4. So as what we have done in the number 1, so we just distribute the exponent to the coefficients. So we have 2 to the power of 4 times x to the power of 4. So let's simplify, which is 2 to the power of 4 equals 16, because if we multiply this one, we have 2 to the power of 4 equals 2 times 2 times 2 times 2. So 2 times 2 equals 4 times 2, 8. So 8 times 2, we have 16. So the answer is 16. Then x to the power of 4. So our answer is 16x to the power of 4. Quotient of powers. For all integers m and n and any zero number a to the power of m over a to the power of n equals a to the power of m minus n. Consider the quotients. So we have 64 divide 16 or over 16 equals 4. So we have, for 64, we have 2 to the power of 6 over 2 to the power of 4. To easily divide this, so we just copy the coefficient 2. Then subtract the exponent, which is as what we have here. We have a to the power of m minus n. So subtract exponent. The exponent of the numerator will be subtracted by the denominator. So we have copy the coefficient 2 and subtract 6 minus 4 equals 2. So the answer is 2 to the power of 2. And for the second one, we have 81 over 27 equals 3. So we have, for 81, we have 3 to the power of 4. Over, for 27, we have 3 to the power of 3. So just copy the coefficient 3, then subtract the exponents. So we have 4 minus 3 equals 1. So the answer is 3 to the power of 1. Therefore, to divide powers that have the same base, exponents are subtracted. Examples. Number 1. A to the power of 5 over a to the power of 2. So, as what we have done in the examples, so we just copy the coefficient and subtract the exponent. So, we have a to the power of 5 minus 2, where a is not equal to 0. So, the answer for that is a to the power of 3. Number 2. M to the power of 5, n to the power of 4 over mn equals m to the power of 5 minus 1, which is 1 is the exponent of the denominator m, times n to the power of 4 minus 1, which is 1 also, is the exponent of the denominator n, equals m to the power of 4, n to the power of 3, where m and n is not equal to 0. Number 3. 12x to the power of 5, y to the power of 4, all over 3x squared, y to the power of 3, equals. So, as what we have done in the previous examples, we just use the commutative and associative property. So, we have 12 over 3 times x to the power of 5 minus 2, y to the power of 4 minus 3, where x and y is not equal to 0. So, 12 over 3 equals 4, and x to the power of 5 minus 2, we have x cubed, and y to the power of 4 minus 3, we have y to the power of 1, or y, which is, it's already have a constant exponent 1. Let's proceed to power of a fraction. A over b to the power of m equals a to the power of m over b to the power of m, where b is not equal to 0 and m is a positive integer. Consider the fraction 2/3 were raised to a power 3. The expression becomes 2/3 to the power of 3. Quantity 2/3 to the power of 3 means 2 to the power of 3 over 3 to the power of 3, which is equal to 8 over 27. For examples, number 1, we have x over y to the power of 3 equals x cubed over y cubed, where y is not equal to 0. Number 2, quantity of 2/3 to the power of 2 equals 2 squared over 3 squared, which is 2 times 2 equals 4 and 3 times 3 equals 9. So we have 4 over 9. For number 3, we have 3x squared over 4y cubed to the power of 3. So we just distribute the exponent to the numerator and denominator. So we have 3 to the power of 3, x squared to the power of 3 over 4 to the power of 3, y cubed to the power of 3, where y is not equal to 0. 3 times 3, 9 times 3 equals 27. X, just copy the coefficient x and multiply that 2 times 3. So we have x to the power of 6 over 4 times 4, 16 times 4, 64. Then y cubed to the power of 3, we have y to the power of 9. Thank you for watching and God bless you all.